Good morning. We are going to wait just a few minutes and see if there's any other people that will join. There's somebody. Piper, Andrew. This is Advanced Algebra 1. Y'all are welcome to watch, but this is 5th periods class, and I'll be doing 6th and 7th periods class tomorrow. Getting things set up. Brittany. Hey, Brittany. I'm not sure who all's going to join. I believe Cadence and Brittany are signed up, and I'm not sure about the others. There is a lag between my speaking and then what shows on the screen, and I am videoing this with my phone and watching on my laptop. So if I get confused, just bear with me. If y'all have any questions, I'm going to wait because the questions don't come to me as soon as you ask them. I'm going to wait until the end and try to answer some questions. I might video call y'all to later to see if you have any questions about anything. And I'll try to go slow so you can write stuff down. It'll help if you write some of this down. Of course, you're going to have the video later that you'll be able to look back at if you didn't get everything copied. I'm going to leave the video on Facebook, and I'm going to upload it to YouTube. Give me just a few more minutes. I see Brittany. And I'm going to go ahead and get started. If there's no one on here, it'll be fine because you'll be able to watch the video later. And let's see. Here we go. Alright, this is Algebra 1 Advanced Algebra 1. Today is the 6th. And we're going to be multiplying radicals. Also, before we get started, those of you that are watching, you might want to get some paper. I think if you just sit back and watch it, you'll forget some information that's important. So get some paper and try to write some things as I go. If you miss it, if you don't get everything copied as I'm going along, remember you can go back and watch the video. But it will help you to kind of, so you won't have so much to do later with copying and everything, to go ahead and try to keep up with me and write things down. Alright, so multiplying radicals. Now, we, on the first video that we did, in lesson 1 and lesson 2, that has been uploaded to YouTube for a couple of weeks, that y'all were supposed to do before this, we simplified radicals. Now, if you didn't do those 2 videos, if you didn't watch them and do that practice material with them, then you may be lost on this. But again, you can go back, you can watch those 2 lessons, you can watch this one on my YouTube channel. And I sent y'all the link to that through email. Alright, so we're going to do multiplying radicals. Our goal is to multiply 2 radicals together and then write the answer in simplest radical form. The new thing that we're doing is multiplying the 2 radicals together. We already in lesson 1 learned how to simplify radicals and write them in simplest form. So what we're going to be doing today is based on this multiplication property for radicals. that tells us that the square root of A times the square root of B is equal to the square root of A times B. In other words, if you're multiplying two radicals together, you multiply the numbers or the variables that are on the inside and make a product out of that. Once you do that, then you have to simplify. All right, so I'm going to pause for just a second and see if you are writing this down to give you a chance. I need for y'all to communicate with me, those of you that are watching. If you will just type a comment that you need more time or that you're ready, just to let me know if I can go ahead and start example 1. Need for yep. All right, I don't see any comments, so I'm just going to go ahead. Example 1, we are going to simplify the square root of 2 times the square root of 5. So using our multiplication property for radicals, all you have to do is multiply the 2 times 5, and when you do that, you get the square root of 10. And then once you get the square root of 10, you've got to ask yourself, can that simplify? Now remember, when we simplified radicals the other day, I gave you a list of perfect squares. If any of those perfect squares can divide evenly into 10, then you would have to simplify this. But there's no perfect square that will divide into 10. I think it might help us if we write some of those perfect squares at the top of the paper so you can kind of see which numbers I'm talking about in case you forgot. So I'm going to write them at the top of my page. Just a few that you want to check to see if they'll go into the numbers that we get when we multiply. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and we could keep going on, but those are some of the perfect squares that I told you to memorize. If any of those numbers divide evenly into this product that we get, then you have to simplify it. So none of them do. 4 won't divide evenly into 10, 9 won't divide evenly into 10, and then we get the numbers that are higher than 10. So we know we're finished, and that is your answer. Very easy, right? The hard part comes in simplifying, of course, and that's what gives students the most trouble, but hopefully after we reinforce it over and over, and you've already supposed to have done an IXL lesson, then you'll understand it. All right, example 2. We're going to simplify 3 on the square root of 6 times 4 on the square root of 5. Now these have numbers on the outside and numbers on the inside. You multiply the ones on the outside together and multiply the ones on the inside together and then simplify those. So 3 times 4 is 12, so 12 goes on the outside. And then on the square root, and then you multiply 6 times 5, which is 30. I'm going to switch pens. I think it's hard to see that pen. Let's see. Let me write over this. 12 on the square root of 30. And again, once you get to this point after you've multiplied, you want to check to see if any of those perfect squares that I wrote at the top, 4, 9, 16, 25, 36, 49, 64, any of those will divide evenly into 30. And if it does, you've got to factor 30 like we learned in lesson 1. But none of those will divide into 30, so you are good. That is your answer. So far, pretty easy, right? All right, example 3. If you'll look at these, there's 4 parts. Example 3, A, B, C, D. It's because they're all practically the same thing. But I just wanted to reinforce it because I saw on IXL, I went through your IXL lesson to pick out problems that were on there and did examples. And there were several of these, so I just wanted to make sure you understood these. First of all, if something is squared, if it's to the second power, that means you multiply it by itself. So the square root of 6 to the second power means the square root of 6 times the square root of 6. And when you multiply the square root of 6 times the square root of 6, you get the square root of 36. And then once you get the square root of 36, you just take that answer. The square root of 36 is 6. 36 is a perfect square. And it just comes completely out of the radical as 6. All right, notice our answer. And notice how the problem started. Let's move on to part B. We have the square root of 9 to the second power. That means the square root of 9 times the square root of 9. And the square root of 9 times the square root of 9 is the square root of 81. What is the square root of 81? The square root of 81 is just plain old 9 with no radical left. It's just 9. Okay, so look at our answer. And look at how the problem started. So what I'm hoping that you see with these two is that whenever you square a square root, the square cancels out the square root symbol and you're left with just whatever's inside the radical. Do y'all see that? So once you learn that and know that, these are easy. If you're going to square a square root, they're exact opposites of each other, so they cancel each other out. And you're just left with what's inside. So there's no need to do the work for this. If you see that a square root is squared, you just say the answer is going to be whatever's under that radical symbol, 10x to the second. That is your answer. Part D, the square root of 14x to the fourth squared. Again, you see that you're squaring a square root. They cancel each other out. So the answer is just going to be what's under the radical symbol. 14x to the fourth. That is your answer. Exactly what's under the radical. In your IXL lesson, you'll have a couple of those. Those are really easy. All right, so now we're going to move up into the difficulty level just a little bit. Y'all know that always happens with example 4. From here on out, I believe most of them, after you multiply the things on the inside of your radical together, you're going to have to simplify those. All right, so the square root of 10 times the square root of 2x. You just multiply 10 times 2x. And that's going to be the square root of 20x. Now, once you have the square root of 20x, remember you have to write this in simplest radical form. So you want to see if there's any way to factor 20 with a perfect square so you can pull that perfect square out. Well, 4 divides into 20. So we're going to factor 20 as 4 times 5. And then remember, you just write your x down because it has no exponent on it. Then you take the square root of the 4. The square root of 4 is 2. That comes on the outside. And then you're left with 5x on the inside. So your answer is 2 on the square root of 5x. Again, this that I just did, that's in lesson 1. I sent you an email saying to watch lesson 1 and to do that work before we start today. So I hope y'all did that so you understand what I just did. If not, you'll need to go back and watch that video. And if any of you have any questions on this, at the end, I will give you some time to type in some questions. Maybe I can answer them. If you probably, once I go over all the examples I'm going to go over, once you practice it on IXL, you'll have a good grasp of it. And then on Friday, when I do a video call, you'll be able to, I'll be able to ask you about it some more if you have specific questions. I can even video call you tonight if you're stuck or anything. All right, let's move on to example 5. All right, here's example 5. Simplify the square root of 20f times the square root of 5f to the second. So we're going to multiply. We're going to start by multiplying these two things together that are under the radicals. So 20 times 5 is 100. I'm going to go ahead and put my square root of 100. And then f times f to the second. Remember, when you multiply with variables, you add the exponents. This is understood to have a 1, so you're going to add 1 plus 2, and you'll get f to the third. Alright, so now we have to go back and do what's in lesson 1 video. Simplify this radical, or simplify the square root. Well, 100 is one of those perfect squares, so you don't have to factor it. You just take the square root of 100, which is 10. That's going to come on the outside, but I'm going to go ahead and write it in factored form because f to the third has to be simplified. So I'm not going to write the 10 down just yet. I'm going to come over here to the side to save room underneath. So I'm just going to draw an arrow right there. And then I'm going to factor 100f to the third. 100 is a perfect square, so I'll leave it 100. Remember, f to the third, this is when you're simplifying variables. That's in lesson 2 video that you were supposed to have already watched. So when we do that, remember we have to go down 1 to the even number that's just below this exponent. That will be f to the second and then times f, because f to the second is a perfect square. So you always have to remember simplify with the odd exponents on your variables. Now take the square root of 100, which is 10. Take the square root of f to the second by halving the exponent, and that's going to be f to the first. And then you're left with just an f on the inside. And that is your answer, 10f on the square root of f. Okay, I hope y'all understand that. Let's move on to example 6. We have the square root of 15xw times the square root of 10w to the fourth power. So we're going to start out again by multiplying these together. 150 times 10, 15 times 10 is 150. So we're going to do the square root of 150. When you multiply your variables, you don't have another x in this one, so you just write your x down. And then you add the exponents on the w's. 1 plus 4 is 5. Okay, so now we want to simplify this radical. So you got to ask yourself, what's the largest perfect square that will divide into 150? I'm going to show you what I do if you don't know it. If you don't know these, you just take your 150 and divide by the largest perfect square that you think might go into it. So remember those perfect squares. I'll write them up here again. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121. I could keep going, but there's no need right now to go higher than 144. So look at all those numbers and see which one you think might divide into 150. Looking at them going all the way down, I don't think any of these do. 25, let's divide 150 by 25. It goes 6 times. So we're going to factor 150. That's 25 times 6. 25 times 6 is 150. There's no need to factor the x because it's just to the first power. And we do have to factor the w to the 5th power. Remember, by making it down one exponent from the 5, which is going to be to the 4th, times w. W to the 4th times w is w to the 5th. Then you go through and all you do is find the perfect squares and bring those out. 25, the square root of 25 is 5. The square root of w to the 4th is w to the 2nd, because you half your exponents. I'm going to mark that out. Then these that are left stay inside the radical. So that's going to be on the square root of 6xw. Whenever you simplify these, you will never have an exponent greater than 1 on these variables inside, because if it's greater than 1, it's not simplified. So that is your answer. All right, let's see. We've got 2 more. We're going to simplify the square root of 2gh to the 5th times the square root of 105g to the 5th h. So again, just like always, we're going to multiply what's under the radicals together. And that is going to be the square root. 2 times 105 is 210. And then when you multiply your g's, g to the 1st times g to the 5th is going to be g to the 6th. And h to the 5th times h to the 1st is going to be h to the 6th. And then we need to simplify these. So let's start with our 210. See if there's any of those perfect squares that I wrote down up here that will divide into 210. So I'm going to show you. I already know what it is, but I wanted to show you what to do if you don't know what it is. I don't know if y'all can see the calculator, but you just start with your 210 and start dividing by the largest number up here that you think could possibly go into 210. You know 100 and above won't go into 210. So let's start with 81. So you just do 210 divided by 81, and you get a fraction or a decimal. So that's not it. 210 divided by 64. You get a fraction or decimal, so that's not it. And you just continue. 210 divided by, where did I get to? 49. That you get a fraction or decimal. 210 divided by 36. You get a fraction or decimal. 210 divided by 25. And you're going to keep going, and you're going to see, divided by 16, that nothing's going to go evenly. 210 divided by 9, and 210 divided by 4. So none of those went evenly. Now, 210 can be factored. It can be factored as 21 times 10, but that doesn't do you any good because one of your factors has to be a perfect square. So because none of those perfect squares divide into it, it's simplified. There's no way to bring any perfect square out of 210, so it stays there. Now the g to the 6 and the h to the 6, you can simplify those because those are even exponents and you can half those. So the g comes out as g to the 3rd. H to the 6 comes out as h to the 3rd, but you're left with your square root of 210 on the inside. And that is your answer. Now, after I do this example, some of you may not have, well, I guess all of you have a calculator because you have calculators on your phones. If you get stuck on these, I might not show it in this video, but when we do a video call, I may show you an alternate method on how to find what comes on the outside. I may even do that after this video. We'll see. Okay, so now on this problem, we have a 5 on the outside, but there's not another number on the outside on the second radical. So you just bring your 5 down after you multiply what's on the inside. So that's going to be 5 on the square root. Multiply 28 times 2, which is 56. Multiply the x's by adding the exponents. That's going to be x to the 7th. And then bring down the y to the 5th, because there's not another y over here that matches. And now we have to simplify what's under here. The 5 on the outside, remember from lesson 1, means that you've got to multiply this 5 by whatever perfect square you take the square root of and bring out from this 56. I believe the highest perfect square factor of 56 is 4. And let me make sure. 56 divided by 4 is going to be 14, I believe. I just want to make sure. Yes. So you leave the 5 the way it is on the outside. We factor 56 as 4 times 14. These are odd exponents, so we have to drop them down to the exponent just below it. So that's going to be times x to the 6th times x to make x to the 7th times y to the 4th times y to make y to the 5th. And now you look through all those factors and you take the square roots of the perfect squares. 4 is a perfect square, so that comes on the outside. But now when you bring the square root of 4, which is 2, on the outside, you've got to put it after this 5. So it's going to be times 2. 14 is not a perfect square. X to the 6th, you half the exponent, and you get x to the 3rd. Leave this x. Y to the 4th has an even exponent, so it's a perfect square. You get y to the 2nd, because you half the exponent. And then you leave the y. So now everything that's not marked out stays inside the radical. 14xy. Now we've got to multiply this 5 times 2 on the outside, and then we'll be finished. 10 x to the 3rd, y to the 2nd, on the square root of 14xy. And that is your answer. Okay, I hope that makes sense. Let me go ahead. If some of you are having trouble with larger numbers, like on your IXL, you may get some really large numbers. I'm going to show you a way that you can find the perfect square that comes out. Let me just do that, and then I'll show you what this... oh, wait. Here's another example. I'll show you with this example then. Let's do example 9. I forgot how many I made for y'all. Okay, so we have the 2 on the square root of 33b to the 4th times 3 on the square root of 22. So I'm going to multiply the 2 times 3 together on the outside, and you get 6. And then let me see what 33 times 22 is. 726. So you're going to get 726 b to the 4th. Now you can start dividing 726 by those perfect squares. That always works. In fact, I'll go ahead and tell you, I think 726 can be divided by 121. It can. And I'm going to go ahead and do it this way and then show you the alternate method at the end. So what I did is I divided 726 by 121. 121 is a perfect square. And so that's going to be 6 on the square root of 121 times 6. 121 times 6 is 726. And then times b to the 4th. And then you take the square root of 121, which is 11. So you're going to do 6 times 11. You can't take the 6 out. B to the 4th, you take the square root and bring it out as B to the 2nd. And then you're left with the square root of 6. Multiply your 6 times 11 and you get 66. B to the 2nd on the square root of 6. And that is your answer. Now I'm going to go ahead and make sure you know what the assignment is, and then I'm going to down here work this problem by using a factor tree. If you don't know right away that 121 will divide into it, I'm going to show you how you can use a factor tree to help you. So that should be enough examples that will help you do well in your IXL. I went through your IXL and worked all the problems to get you up to an 80 to make sure there was nothing thrown in there that I had forgotten about. So I think this will get you through that. You need to do lesson EE4 in Algebra 1, get a SMART score of 80, and then your next live lesson will be on Wednesday. You need to go ahead and do this IXL while this is fresh on your mind today, sometime today. I would go ahead and do it. And then if you are having trouble, you can send me an email, and I will do a video call with you and see if I can help you if you get stuck on any of this. So you can leave now if you want to. I'm going to go ahead and do this problem again and show you how to use a factor tree to help you bring out the perfect squares. Alright, so right here, let's just start with what we had when we multiplied. 6 on the square root of 726 b to the 4th. So you can come over to the right and just write your 726 down without the square root and forget about the square root for a minute and do a factor tree on this. If y'all can remember back from middle school with factor trees. You just want to factor 726 until all of the factors are prime. And so I'm just going to start off by saying 2 times whatever it takes to make 726. 726 times 2. Oh, not times 2. 726 divided by 2 is 363. And so you have 2 that's prime, so we're finished with 2, but we've got to keep factoring until all the factors are prime. 363 can be divided by 3, which is a prime factor. And it goes 121 times. And then 121 is not prime, it is 11 times 11. And then all of our factors are prime. So you can say 6 on the square root of 726 equals 6 on the square root of 2 times 3 times 11 times 11. And then for every 2 factors that are the same, you bring that out. So here's 11 times 11, that's 2 of them. So you bring one of those out, and you'll have 6 times 11, and then you have 2 times 3 left on the inside. So you get 66 on the square root of 6. Okay? So this is just a little alternate method if you have a hard time figuring out what the perfect squares are. When you do your factor tree, every pair of like factors comes out as 1 because that's your perfect square. Alright, I will see y'all later. Let me know if you have any questions through email, or I can look for comments. And take care of yourself. I miss you. Bye.